Hi, good day. Today we are going to continue with the last method of solving system of linear equation, which is iteration method. For this iteration method, uh, I will discuss Gauss-Seidel iteration method. So let's start. So for the iteration method, okay, similar to the previous one, okay, when we want to start doing the solve the system of linear equation for different methods, we have to make sure that is um, fulfill the criteria. Okay, for the iteration methods, okay, the method must be satisfied. It should be satisfied convergent criteria. What is convergent criteria? Convergent criteria, that's mean, sorry. A matrix A must be diagonally dominant. Oops, sorry. Diagonally dominant, okay? So, for example, let's say the matrix have a dimension of n times n. The diagonally, it is strictly diagonally dominant if and only if when the AII of the matrix A is larger than the summation of Aij, whereby j is equal to 1 and j cannot be equal to I. For start from j equal to 1 until n, for all I equal to 1, 2, and until n. Okay, so and then we have to do, okay, so we go to see what is this diagonally dominance means. Okay, if let's say we have a matrix, let's say like this, 3 times 3. Let's say we have matrix 3 times 3. Okay, so and then did you remember that last time? What is this one? This is the leading entry, right? Oops, this is so big. So this is a leading entry. So if let's say AII, that means this the value of those value at the leading entry. So AII, that means A11 and also A22 and also A33. Okay, so that means A11 in modulus value have to be larger than, okay, summation of Aij. That means summation of A12 and A13. That means, sorry, A12 plus with A13. Okay, so for A22, that means have to be bigger than A21 plus with A23. And A33 in modulus have to be bigger than A31 plus with A32. So if let's say it can fulfill all the requirements here, these all three, that means this matrix is a convergent matrix or diagonally dominant. Okay. Diagonally dominant. Okay. Okay. sorry, before I go to more details, I forget to inform you, if you want to refer to your books, then you can turn to uh, page 58 for the iteration method. Okay, so, and when we already have the matrix, make sure that the matrix is diagonally dominant, and we solve using these iteration methods, and we have to do the iteration methods. So the iteration method, that means we have to draw the tables like the previous chapter in chapter 2. Gauss, so, and then we only can stop. Okay, we start with the, once this is already, and this is a diagonally dominant, then we can solve using iteration method, and where we do the start with the initial guess. So initial guesses. So depend. You will start with which guesses, and then we will do the iteration until the stopping criteria. Stopping criteria. Sorry, so I have to. Sorry, we continue. Okay, the stopping criteria, we only can stop when the maximum of the magnitude for the x k plus 1 level minus the x level of k, the iteration of k level in the modulus, okay, less than epsilon. So if let's say that we do the calculation in 4 decimal places, that means the epsilon will be 0.005. Okay, so we try to check whether the metric is diagonally dominant or not. Okay, by let's try the example. Example 3.18. Okay, in page 59. So in this, the example said, show that the matrix A, this matrix 9, 6, 2, 2, -5, -2, -3, 1, 7 is diagonally dominant. So we have to check using this criteria just now. This criteria. So using this criteria. Okay. So the first one, okay, this is a diagonal line, right? Okay, so remember A11, okay, in the modulus have to be bigger than, for the same line, if let's say for the same line, sorry, this one, for the same rows, that means A1, 2 plus with A13. Okay, so here 9 is larger than 6 plus 2. Okay, so this one larger than 8. Okay, so this is correct. Okay, this is true. Okay, this is okay. And we check the second rows. A22 have to be larger than A21 plus with A23. Okay, check with this one. A22 have to be larger than, yeah, we change another color. So this A22, this A22 have to be larger than these two. So A to 2 is negative 5 in modulus, have to be larger than 2 plus with minus 2. Okay, so this 2 is in the modulus actually. Okay, so become 5 have to be larger than 2 plus 2, that's 4. So 5 bigger than 4. So this also is true. Okay, then the next A33. So I draw it as here. Okay, so A33 in modulus have to be bigger than, okay, A31 plus with A32. Okay, so if look at here, A33 is this one, have checked whether this one plus this one. So here become 7 bigger than, okay, negative 3 plus with 1. So 7 larger than 3 plus 1, 4. So this also true. So when this all true, that means this matrix A is diagonally dominant. So once it's diagonally dominant, then we only can use this matrix to solve the system of linear equation using iteration methods. Okay. If it is not diagonally dominant, then we cannot solve using iteration methods. Okay. So maybe you can try another example. Okay, later on. So maybe I will jump into Gauss-Seidel iteration methods. Okay. So I will move to Gauss-Seidel iteration method. For the Gauss-Seidel iteration methods, you can turn to page 60 in your book. Page 60 in your book. Okay. So it say here, if let's say consider we have an equation with n unknowns. Let's say we have n equation, consider that we have n equations with n unknown. So let's say we have a11 x1 plus with a12 x2 plus with a13 x3 and lagi lah a1n xn equal to b1, and then a21 x1 plus a22 x2 plus a23 x3 plus a2n xn b2, a31 x1 plus a32 x2 plus a33 x3 plus a3n xn equal to b3 until, let's say we have a lot, until an 1 x1 plus an 2 x2 plus an 3 x3 plus until an xn equal to bn. Okay. So, and the first step, because we have to make sure this metric is diagonally dominant, so we have to rearrange so that the metric is, so the first step we have to make sure rearrange so matrix A is diagonally dominant, or we say that it's achieved convergent criteria. Okay. And then we can do the write down the iterations formula. So the second step is we do the Gauss-Seidel iteration formula. Okay. So look at here. When I want to find the x1, okay, look at the first equation here. First equation here. Okay. If I want to find x1, right? I want to find x1. So the formula will become x1, okay? I will find the next level of x1, k plus 1, okay? Will equal to b1, okay? So the rest, this this a12 x2 a13 x3, I will put to the right, right? Bring to the right. So b minus a12 x2 minus a13 x3 and minus lagi lah sampai ke this one lah till n lah, minus a1n 1n xn, okay? And then we divide by its own value, right? Divide by a11. Okay. So and then this is okay, this is the k plus 1 level, and this is the level of k, level of k, level of k. Okay. When I want to find the x2, so the similar thing, go to this one, the second row, the second equation based on these second equations. Okay. So this will be x2 equal to b2 minus, okay, a21 x1 minus a23 x3 minus until a2n xn divide by itself. This one, a22. Okay, so this one, this will become the level of k plus 1. Okay, just now, because x1 we already have k plus 1 level, so this x1 will be level k plus 1, and this will be level of k, level of k. Sebab kenapa? Sebab sebenarnya sebelum ni tadi kita dah cari this level k plus 1. So ini akan jadi level k plus 1 lah. Tapi x3 kita belum lagi. Okay, and this one xn pun belum, so it will be in a k level. So when we want to find x3, yeah, based on this equation, right? So it's linear equation. So when you want to find x3, so x3 level of k plus 1 will be equal to b3 minus a31 x1 level of k plus 1. Sebab kita k yang ni, because just now we already find this one at level k plus 1. And then minus a32 x2. Okay, so this also k plus 1 level. Sebab tadi dah cari ini. Kita akan ganti yang the latest. We will substitute the latest value. Okay, and then minus until a3n xn lah. So this is level k. Divide by, if you look at this one, okay, so divide by this value a33. Okay, so this is a formula of the Gauss-Seidel iteration formula. So based on the equation, we get the x1, x2, x3, and then we start with the initial guess. Step 3, we will start from the initial guess. So normally we'll start with the initial guess of X, the zero iterations, okay? Biasanya we start with the 0, 0, 0 lah. Maksudnya X1, we assume that is 0, X2 is 0, X3 is 0. So we will put in the table, normally in the tables, like this. Okay, this is a K, this is a X1, this is a X2, this is a X3. So start with the 0 iterations. This is 0, 0, 0. Kalau let's say in the exam or task, this one initial gas diberi, so you use the initial gas that provided. If not, we just start from 0, 0, 0. So and then we do the iterations until stop lah. That means we iterate until the maximums of many tubes xk plus 1 minus xk is smaller than epsilons. That means, let's say this value, this is level k 2, 3, 4, 5, and 6, so on. So we have to compare this value with this value. Compare. Have to be less than epsilons. And this value have to compare with this value. Have to be less than, and check this value and this value. So these three, 1, 2, 3, which one is the biggest? Okay, and then we compare the maximum. Compare sama ada the biggest antara tiga ni, adakah tiga-tiga yang paling besar ni, is it less than epsilon? If less than epsilons, then mean kalau less than epsilon, that mean all, mesti semua tu lah, maksudnya semua, all of this x1, x2, x3 dah kita dapat dia punya perbandingan, we will get less than epsilon. That means we can stop the iterations already. So that means the last iteration will be, the value will be at that particular value. This x1, x1, x2, x3. This is the value that we need. Okay, maybe you will a bit blur, so maybe we just jump to the example so you'll be more clear. Okay, so let's go to the example. Okay, let's do example. Start with the example in your books. Example 3.21, okay? So this is page 61 in your book. So given this equation, 2x1 plus with 3x2 plus 10x3 equal to 9, and then 5x1 minus x2 plus 3x2 3 equal to 6, 4x1 plus 7x2 plus x3 equal to 2. So first of foremost, the step 1, we have to rearrange, okay, if needed lah, to make sure that rearrange so that matrix A is diagonally dominant. So make sure it is diagonally dominant. Oh, sorry. Okay, so we check. So for the first row, if you look at first row, okay, so we have, see first row, this is the largest, right? 10. So for sure, basically we will have to put this one in the row 3. But before that, so we have to check whether this is a diagonal dominance or not. That means we have to find whether this A33, is it in the modulus larger than A31 plus with A32. Okay, so that means 10 larger than 2 plus with 3. Okay, yes, that is true. Okay, so this one will become row 3. So, and then look at this one. Among the second rows, among this one is the largest, right? X1. So probably we can put it in this one in a row 1, and we can check A11 modulus, is it larger than A12 plus with A13. So 5 larger than -1 plus with 3. Okay, so 5 larger than 4. This is also true. Okay, and then this one you check for the for the third rows. This one is largest value, so probably we can put this one at the row 2, rearrange into row 3, and we can check whether diagonally dominant or not. A22 have to be larger than A21 plus with A23. So A21, A22 is 7. 7 have to be larger than 4 plus 1. Okay, that's correct. True. So this matrix we have to arrange become, okay, row 1 is 5 x1 minus x2 plus 3x3 equal to 6. Okay, and then row 2 is 4x1 plus with 7x2 plus x3 equal to 2. And then the third row is 2x1 plus 3x2 plus 10x3 equal to 9. So depend whether you want to write in these linear equations like this, or you also can write in the metric form. 5, -1, 3, 6, 4, 7, 1, 2, 2, 3, 10, 9. Okay, you can even write in the metric form like this. Okay, after rearrange the matrix so that it become diagonally dominant, then after that we can write the formula of Gauss-Seidel iteration formula. Step 2, write formula. Okay, so start with, we want to find the x. Okay, find the x1. So x1 will become 6 plus with x2 minus x3 divided by 5. Okay, and then x2 equal to the second row, this one. Okay, 2 minus 4x1 minus x3 divided by itself 7. Okay, and then x3 equal to, okay, sorry, this one, this is based on these equations. X3 equal to 9. Okay, so yang others bring to the right become minus 2x1 minus 3x2. So bahagi dengan dia sendiri, divide by itself 10. Okay, so in the calculator, in order to make us more easier to put in the calculator, I will put assume x1 as A, and then x2 as B, and then x3 as C. Okay, so okay, basically this is level k plus 1, this k plus 1, k plus 1. So let's say this one, this is level k. So you don't want to write this one also, doesn't matter. So I just inform you this one is because x plus 1, we already do the newer, they already get the level k plus 1, and this one is level k. So at here we get k level k plus 1 and k plus 1. Okay, so daripada sini, okay, I will change this one into this using calculator punya formula. So A, okay, because x1 is become A, right? A equal to 6 plus with B minus 3C. Okay, divide by 5. And then, dalam calculator, saya akan perlu letak double dot macam ni. And then, saya akan tulis B equal to, so that I just key in once only. All of this formula key in one time. Okay. B is equal to 2 minus 4A minus C divide by 7. And then C equal to 9 minus 2A minus 3B divide by 10. Okay. And then I will solve. Okay. So wait, I draw the table first, and then we do try to use calculator. So step 3, I will have to do the initial guess. Initial guess where I will use x equal to 0, 0, 0. Okay, sebab dia tak beri, kita ambil je. And then do the iterations. Okay, so that means in the table we need a table that consists of k, x1, x2, x3. Okay, so here that means this is a A. Saya ambil color line. This is A. Tak boleh nampak. A, this is B, this is C. Okay, let's key in the calculator using these equations. So, start with the first iteration, 0. All of this value, if initial guess is 0. Okay, so I will want to find the next value of this x1. Okay, so I will put in the calculator alpha. I use mouse. Okay, sorry. Okay, alpha A. Alpha A equal to, okay, the equal is alpha equal here, the red color here, equal to, and then pecahan 6 plus alpha B minus 3 alpha C, and go down, this is 5. Okay, and then press to the next. So I want to key in this column, yang ni, titik, dua titik ni. So this is an alpha, this one. Okay, so I put alpha B, another equation, the second equation, alpha B, alpha equal to, okay, pecahan lagi, 2 minus 4 alpha A minus alpha C, and then go down, that is 7. Okay, bring to the right, and then saya masukkan ni tanda dua titik, alpha, this symbol, and then alpha C equal to alpha equal, okay, pecahan, this is 9 minus 2 alpha A minus 3 alpha B divided by 10. Okay, so I use this one, calculate. So it will ask us, okay, because now I want to find x1. X1 is A. If look at here, A, it will ask us what is B and what is C. So based on this one, the B, previous B, this is a 0, and this also will become 0. So B is 0 equal to, and C also 0. So you get the answer 6/5. That means 1.2. So this is 1.2. Okay. And then tekan saja sama dengan, okay, if you directly give you answer for B. Because why? Because it already, untuk B, dia punya A adalah based on this value actually. You look at B equation, that means we need to key in A and C. So A is based on this one and C is based on this one. Because it's already helped us to calculate just now based on the latest value of A, bukan lagi kosong tapi value is 1.2. So, and then the C is 0. So you get this one minus 2 over 3. That means we get this value is negative 0.4. So awak tekan sama dengan saja, and then we will continue get your result. And then in order to find C, tekan equal to. You just press equal and then it will give you the answer of C. So the answer of C is 0.78. Okay? And then you just press equal to again. You no need to change anything, no need to key in anything because the calculator will automatically for the another A, let's say this one for this value A, it will use this B value and use this C value. So you just press equal to, okay, so you no need to change because B actually negative 2 over 5 is actually this value already, negative 0.4. So just press equal to, so you get the value of A. So this is a new A. So just press in, just key in this value. Sorry. So let's say delete. Oops. Yeah. So this is 0.652. And then just press equal to, so you get the value of B, negative 0.1983. Okay. And then press equal to, you will get value of C, 0.8291. Okay. And then continue, sama juga. You no need to press a key in the value, just press equal to. So equal to, okay, equal to, so you get A, the value of A, and then press equal to, you get value of B, and then press equal to, you will get the value of C, 0.8309. Okay, and then press equal to, okay, you ask you, is it B is negative 0.21? Okay, it's already using the latest one. So you just press equal to. So you get a new iteration number 4. The value of A is 0.6592 and then equal to negative 0.2097 and then equal to 0.8311. Okay. Okay, since adakah kita boleh stop now? If you look at here, yang ni, this one minus this one. Belum dapat less than 0. Dapat tak? 11. Okay, that means 0.0003. But how about this one? Okay, we haven't get less than epsilons. Okay, so we have to continue. So continue. Just press equal to, so you get the next value of A. That means 0.6594 and then press equal to negative 0.2098 equal to 0.8311. So look at this one, okay? If you look at this one, you see, you compare. Okay, let's say compare this one minus this one. Okay, now let's say we do this one. This one compare with this one becomes 0.0002 and this one compare with this one 0.00 in the modulus 0.0001. This one 0. Okay, so basically we can stop until this iteration iteration number 5, the 5th iteration, because since we can write, okay, since the maximums of the magnitudes of, okay, x5 minus x4, okay, is which one? This one is, which one is, okay, is like this. You can use it 0 0.002, 0 0.001, 0 0.0000. Yang ni kan? Sorry, maximum here. Is equal to which one? Among these three. This one, this one, this one. So this one is the maximum. So this is 0 0.0002 is less than epsilon. Okay? So we already can stop lah. Right. So x at the fifth iteration equal to, this is the value of x, okay? 0.6594, okay? We no need to put comma, just a space a little bit, negative 0.2098, space a little bit, 0.8311. So this is the in the metric transpose, yeah? Transpose. Sorry. Because actually this is the, macam ni kan biasanya x1, x2, x3. Sama dengan this one lah, this one. Depend on how you want to write. If you want to write in this form, so no need transpose. If you want to write in this form, so you make sure you have to put the transpose sign. So this is the Gauss-Seidel iteration methods. It's more simple. So how about, let's I teach you how to do use this calculator, the old version of calculator when you want to key in those equation just now. Ini we go back to just now. Okay, this one. Key in these three formula. Okay. So in this one, okay, you just key in alpha A, alpha equal to, okay, pecahan yang macam ni, 6 plus with alpha B minus 3 alpha C, sorry, oops, alpha C, and then divide by 5. So ke kanan, okay, and then you look at here, yang double dot kat sini alpha titik, 2 titik tu. Alpha B, alpha equal pecahan, okay, 2 minus 4 alpha A minus alpha C divide by 7, okay. Pergi ke kanan lagi, double dot kat sini, okay, and then alpha C, alpha equal pecahan 9 minus 2 alpha A minus 3 alpha B divide by 10. Okay, so you just press equal to, oops, syntax error. What's wrong with my equations? So kat sini macam ni lah. So alpha A, alpha equal to, sorry, alpha equal to pecahan 6 plus alpha B minus 3 alpha C, oh lemak, alpha C bahagi divide by 5 and then go to this symbol alpha B, alpha equal pecahan 2 minus 4 alpha A minus alpha C and then divide by 7 and then go to the right, get this symbol alpha C, alpha equal pecahan lagi 9 minus 2 alpha A minus 3 alpha B divide by 10, okay. So use the calculate, calculate bukan sama dengan, sorry, calculate. So B is 0, initial guess, C is 0. So you get this value just now, 1.2, and then just press equal to, you get the another B value, and then press equal to, you get the C value or x3, and then just press equal to, continue. So you get the next value. Okay, so you get next value 0.652 and so on. Okay, so I think that's all for today. So we will meet you again in the next video. So I think that's all for the chapter 3. So we already finished all the chapter 3. So see you again in the next video.